Hi everyone, in this article I'm going to discuss different types of idle actuators, how to wire them to a modular ECU, how to configure the outputs in the software. I'll not be discussing how to set up the open loop or the closed loop idle because I'll have other articles to explain that. First of all, let's talk about different types of idle actuators. There are 4 types that we support, and the easy way to categorize them is by the number of pins. 2, 3, 4 and 6. Now this may work with other types of actuators, but we don't support those. Now the most basic type is the 2-wire solenoid. These can be found on Fords, Mazdas, Nissans and some Honda engines. Normally one side is connected to a 12 volt supply and the negative side is connected back to the ECU output, which switches to ground. When the ECU switches it to ground, the solenoid opens and allows more air to go into the engine. So generally it's pulse width modulated by the ECU to be able to control a variable amount of air. Now sometimes these guys have got an internal diode, which means that you need to get the polarity on them correct. Now you can check this with a multimeter, I won't go into how, or the other thing you can do is follow the factory wiring diagram. So you get the same pin on the positive as the factory got, then it's going to be correct. So to connect this, you connect the positive side to a 12 volt ignition switched source, and you connect the negative side to an output on the ECU. Now the output needs to be a high current one, so it can either be an auxiliary output or you can be an injector output. Now that output type then needs to be configured as being idle effort PWM. The PWM frequency may take a little bit of experimenting. If the frequency is too high, then what can happen is the valve can actually get stuck at a certain location, and you can vary the duty cycle a little bit and the difference in force isn't enough to overcome the static friction. However, if you lower the PWM frequency, then the valve actually oscillates a tiny little bit, and that's enough to overcome the friction, which actually gives you better control then. The downside with the frequency being too low is that as the valve oscillates backward and forward, even a little bit, that creates an oscillating pressure wave, which we know is sound. So often you can actually hear the idle valve wiggling through the intake system of the car if the frequency is too low. So therefore, lower PWM frequencies give you better control, but if it's too low, then you're going to be able to hear it, and that's not very nice. Some frequencies we use are about 100 Hz on the RB and the SR Nissan engines, and actually the same on the Mazda 13B engines as well. On the Mazda B engines, like on the MX-5s Miatas, we generally run them about 500 Hz because of this noise effect. Now you can check that it's connected electrically by looking at the diagnostic screen or the F11 window for that output. For example, if the engine stopped, then the ECU drives the idle output at 100% duty cycle. So in that case, the idle valve will be on. You should see a low voltage, so close to 0 volt, and the current that appears on the output should be the current of the valve, so an amp and a half, that sort of thing. Now if the output's off, so for example if you change it to be none rather than idle effort, then the voltage should be shown as being the supply voltage, so about 12 volts, and the current should be 0 because we're not driving it. Now the next type is the 3-wire idle motor. One type of these is the Bosch 3-wire idle valve, which is quite a big device, and I've also seen them on some Toyota engines as well, little 4-cylinder guys, and also some Subaru engines. Now there's a standard way to connect these and also an alternative way, so I'll discuss both of them. The first way is that the 3 pins actually form a center tapped motor. So normally the middle pin needs to be connected to 12 volts and each of the other sides needs to go to a high current output on the ECU. So an auxiliary output or an unused injector output. One of the outputs needs to be configured as idle effort PWM and the other needs to be configured as idle effort inverted PWM. Now the one that's the idle effort needs to be the one that you pull to ground, and that opens the valve and lets more air in and increases the idle speed. Now if you don't know which one that is, you can just set it up, and then once you've got it running, you can check if a bigger number makes it idle higher or lower. And if it's wrong, then you can just invert both of the outputs so that the first one is now idle effort inverted and the second one is now just idle effort. Now PWM frequency, generally we've found about 250 Hz works well. There may be some other valves where it doesn't, or a lower frequency gives you more induction noise or something like that. I'm not sure. I'd start with 250 Hz and then follow the rules that I said about the 2-wire solenoid. Now you can check that the outputs are working in the same way that we checked the 2-wire outputs in the previous example. Now another way that I've seen these connected is instead of connecting the middle terminal to 12 volts and then each of the other sides to ground alternately, what you can do is you can connect one side to 12 volts or the other end to ground, and then the middle terminal to a push-pull auxiliary output on the ECU. So that means that when the ECU is pulling the output low, then the side which has got the 12 volts applied to it is on and the other side is off. because it's got 0 volts on both sides. And if you switch that output high instead, then the first one has got 0 volts across it because they're both at 12 volts, and then the other one has got 12 volts across it. And this is how they're connected from the factory on the Lotus Series 2 Elise and Exige cars with the 2ZZGE engine. Interestingly, on the Toyota incarnation of that engine, so in the Celicas, they're connected in the normal way with the middle terminal connected to 12 volts and each other side going back to the ECU. Maybe they ran out of pins on the ECU, who knows. The next type is the 4-wire idle stepper motor. So far I've only seen these on General Motors engines, but maybe because they're popular on those, they've become popular in aftermarket installations as well. These have 250 steps and they have 4 wires on them. The 4 wires go to 2 coils inside the motor and they need to be driven with push-pull outputs. Usually the pins are labelled as A, B, C, D, with AB being one coil and CD being the other coil. Each coil needs to be driven high at one end and low at the other, with the direction changing depending on which step they're up to. Therefore, to drive one of these outputs, you need to be able to use 4 push-pull auxiliary outputs on the ECU, so not injector or ignition outputs. And they must be configured as drive high. Here are the settings that are required. Now, to check that the ECU is driving the outputs correctly, set the outputs as follows and check that the voltage is shown in the software. And now you can invert the outputs and again check that the voltage is displayed correctly. Now if the current is shown as 0 on an output whose voltage is 0, that means that either there's a bad connection somewhere between the ECU and the motor on that pin or the corresponding pin, or the motor itself is open circuit on that winding. Now if the voltage doesn't switch between 0 and 12 volts correctly, but the ECU setting is correct, then either there's a short circuit somewhere or the output driver in the ECU has been damaged. Now if your 4-wire stepper motor pins are labelled differently, then you can use a multimeter to work out which pins are joined together internally. And in this case, the direction could still be reversed. That is, a higher number could actually correspond to a lower RPM. If that's the case, then just swap around C and D. So C becomes stepper B and D becomes stepper B inverted. Now at the moment we recommend using the home motor's home at startup because it really simplifies the AFI power wiring and it's fairly foolproof. Now the last type of idle motor that we'll discuss is the 6-wire idle stepper motor. These are similar to the 4-wire motors, except that each row of pins has got 3 pins and the middle pin of each needs to be connected to an ignition switched 12 volt supply. Now each of those outside 4 pins then needs to be connected to an output on the ECU. It's fine to use unused ignition outputs or unused injector outputs or auxiliary outputs to drive these because the stepper motor draws very little current. So then the outputs need to be configured in the same way as the 4-wire stepper motor, except without the drive high enabled, because we're only pulling to ground because we've got the 12 volt supply on the middle pin of the motor anyway. Now, just like with the GM 4-wire stepper motors, we need to configure the number of steps and the step period. So unlike 5 milliseconds, which is what the 250 step motors use, often the 6-wire ones need about 10 milliseconds to step correctly without skipping steps. What I've found so far is that the Mitsubishi motors tend to be 120 steps and the Toyota about 125, so enter those values. And again, we recommend using the home at startup mode. Now, just as with the 4-wire stepper motor, depending on exactly how your stepper is wired, the above configuration might actually give you the wrong direction, that is a higher number corresponds to a lower RPM. So if that's the case, then just swap the last 2 outputs around like this and you'll be sweet. Now to test the outputs are connected correctly, what you should do is set each output to be none and then verify that they all show 12 volts. Now as each output is inverted, the output voltage should go down to 0 volts and you should see the current increase. Now if the voltage doesn't go to 0 volts and it stays at 12 volts, then that means that either there's a short to 12 volts somewhere or that output of the ECU has been damaged. If the output wasn't at 12 volts in the first place, then that normally means that there's a bad connection between the ECU and the stepper motor, or you don't have 12 volt power to the stepper motor, or the coil in the stepper motor is open circuit. Now just a final word about some of the definitions that we use in the software. So the stepper motor A and stepper motor B duty cycle outputs are going to flick between 0 and 100%. This is to generate the quadrature waveform that actually drives the stepper motor forwards and backwards. You won't be able to see this on a log file because it happens too quickly, but you can see it on the built-in scope or with a real scope if you want to. Now the ECU calculates the idle effort as though it were a duty cycle, so 0 to 100%. It calculates it to a resolution of 0.01%, so there's plenty of resolution there for idle steppers that have got more than 100 steps. The ECU then converts that percentage into a step number based on the maximum number of steps on the motor. So for example, if the idle effort is 50% and you have a 250 step motor, it will try to move to step number 125. Now the other flag that you need to be able to see is that idle homed. So this is what the ECU does when you first turn on the ignition power. It drives the motor fully back to allow the engine the most air so it can start. And once it's done that by stepping through the complete number of steps of the motor, then it knows that it must be able to count from that position onwards, because we know that the motor's got to its end of travel. Unfortunately, these motors never have position sensors on them, so all the ECU can do is count the steps. Thank you very much.